Okay, in this video we'll take a look at graphing and solving radical equations. So let's start off with this example, which is we want to solve 0 equals the square root of x plus 2. I'll take away x. And to start with, we want to do this graphically. And we'll take a look at algebraically in the next couple of examples after this. So graphically, well, we want to actually graph this, and we had some practice doing that in the last video. So some steps to this are to think about what's the domain, and in this case the square root has to be positive, so x plus 2 has to be greater than or equal to 0, which means x has to be greater than or equal to negative 2. So when you're sketching this graph, you know that you really only need to choose values greater than or equal to this negative 2. So negative 1, 0, 1, 2, 3, 4, and we'll see what happens in that direction. So I've already started to set up my sketch. My next step is to basically just make a table of values, and so I can choose x values and corresponding y values. So let's see what happens when it's negative 2. That would be 0 minus negative 2, which is 0, plus 2, which is 2. So my graph starts here. And then what happens at negative 1? Well, negative 1 plus 2 is 1, square root of 1 is 1, 1 plus 1 is also 2. So, sorry, I had the first point in the wrong spot, but it worked out okay. And then I continue. What happens when x is equal to 0? So it's the square root of 2 minus 0, so just the square root of 2, which is 1.4 or so. And what happens when x is 1? Well, I get the square root of 3 minus 1, and you can grab a calculator and see what that's worth, but about 1.7 take away 1 is about 0.7. So, and what happens with this graph is it actually goes up. You can check by seeing what happens at negative 1.5. It goes up and then it starts coming down like this. It's a little bit of a smoother curve than I have here, but it starts coming down. In fact, I believe it hits at 2. So 2 plus 2 is 4, square root of 4 is 2, 2 minus 2 is 0. So it hits exactly here at positive 2, and then it cruises down. And that's what I wanted to know, is when does this function, if you think about this as f of x, when does this function equal 0? And that function equals 0 right here, or graphically right here. And so I have my answer, which is x is equal to 2. So you generate enough of a table of values, or doing it graphically, so we're using both of these things here to get our final answer. Now if it didn't cross perfectly on the x-axis at exactly 2, then I'm going to have to use estimation or just try and guess where it is, which is why an algebraic approach is so much better in a lot of ways. So let's see if we can generate the same solution taking a look at this from an algebraic approach. So exactly the same question algebraically. First step here is to isolate the radical to one side of the equal sign. And so doing that, I'm just going to add x to both sides, and I get my radical nicely isolated on one side. And now if I, in this case it's a square root, now if I square both sides, but basically raise both sides to the power that's equal to the index of that radical, then that's my next step. And that helps clear out the radicals. So there's my question, and this is the step that I'm doing. I'm squaring this side, because square roots and squares cancel each other out. And what I do to one side of an equation, I do to the other side of the equation. And so I end up with this, which is a quadratic, and I can solve that, which is my next step. And in this case, I'm solving by making it equal to 0 and factoring it. So x minus 2 and x plus 1, and I now get my two solutions. Now, last time we did this graphically, we didn't see those two solutions, we only saw one solution. So there are extraneous roots, and we need to discard them as step 4. And there's a couple of different ways to discard extraneous roots. I like just checking them in the original equation. So when I put 2 back into the original equation, and again that was 0 equals this root x plus 2 minus x. When I put 2 back in, I get 0. When I put negative 1 in, I get 1 plus 1, which is 2. So that's why this one gets taken out, and I just get a final answer of x is equal to 2. You can also check them against the domain of the original equation. We know that all the values have to be 2 or bigger, so negative 1 isn't in that domain, so we just discard it. Let's take a look at one more example. So again, we're solving this equation algebraically. So the very first step is to isolate the radical. So put that on one side, x plus 1 to the other side, raise both sides to the power that I need to raise them to. In this case, it's squared. This simply cancels out that square root. And by canceling out the square root, I just get x plus 2. This one's a little trickier. You have to think about it as x plus 1 times x plus 1 and use the distributive law. So you'll get x squared plus 2x plus 1. And now we solve this. So get everything, make it equal to 0. So subtract an x, subtract an x, subtract 2, subtract 2. You can try and factor this. Are there two factors that multiply to negative 1 that add up to 1? Multiply to negative 1 and no, that's impossible to do. If you can't factor, you could complete the square or use the quadratic formula. I like the quadratic formula a little bit better, so negative b plus or minus b squared minus 4 times a times c all over 2a, and I get negative 1 plus or minus, this works out to be 5 over 2. And so I get negative 1 plus root 5 over 2. I also get negative 1 minus root 5 over 2. But if I check the domain on this, x has to be greater than or equal to negative 2. And when I check these as decimal places, this second one does not work. It's too small. And so therefore I just have one answer, which is x is equal to negative 1 plus root 5, all divided by 2.